All right, y'all. So 9.1 deals with something that we call composition of functions. All right, so basically the composition of functions, this is going to be when we use a function as the input values of another function. Okay, so we're going to put a whole function in for the x's of the other function. So we got symbolism we use in this section. The first symbolism is F compose G of X. And y'all, that's not a zero or a O. That's like a little symbol. Looks like a degree symbol almost. Okay, so that just lets us know we got a composition of functions. So what this means when it's in this kind of notation, this is the same as F of G of X. So in this case, the G of X function is put into the X's for the F function. So the G of X function is put into the X's of the F of X function. So they'll give me a F of X and a G of X. And I'm going to take that G of X and replace the X with that entire function, okay? And y'all, the second one's really similar. It's just reverse. This one will have G compose F of X. So this would be like doing a G of F of X. So in this situation, the whole F of X function is put into the X's of the G of X function. So the F of X function is put into the X's of the G of X function. Hey, also, that's the symbolism we're looking at for today. So they'll start out giving me a numbers in place of the X's. So I'll evaluate G of whatever that number is and then put that answer into the F. Same thing here. If I get numbers on the G of F of X, I'll put the numbers into the F of X function. And whatever I get on that answer, we'll put into our G. So they'll start out doing that. Now at the end, they're just going to have a simplify. So that's when we will put the whole function in there, okay? So they start out, like I said, doing the numbers, and numbers probably are not quite as bad. So y'all, let me give you an example here. So for this one, they want to let f of x equal negative 5x minus 1. G of x, they want to equal x squared minus 2. So on this one, they want us to find f compose g of 2. So they gave us a number on this one. So remember, this, I'm going to write this as this notation here. So this one would be f of g of 2. So since I got a number, we're going to start with g of 2 and see what that equals. Once we get what answer g of 2 is, we're going to put that into f, okay? So first, we find g of 2. Then put that answer into the f of x. So I'll be finding f of whatever g of 2 gave me, okay? So y'all, let's do that. Let's find g of 2 first. Well, g of 2 is going to equal the g of x equation. Put in a 2 for those x's. So that's going to give me a 2 squared minus 2. All right, so order of operations, we'll hit the exponent first. 2 squared is 4. So I get 4 minus 2, which is 2. The 2 now goes into the f of x function. So whatever number I would have got here is going into the f function, okay? So that means I'm finding f of 2. So f of 2 will equal negative 5 times 2 minus 1. All right, y'all, so I'll multiply first. Negative 5 and 2 give me a negative 10 minus 1, which gives us a negative 11. Final answer. So these are basically almost like two-step problems. Okay, you work your innermost parentheses first, and then that answer is going into the outer function, okay? All right, let's try this one. They're giving us f of x equals 3x plus 1. G of x is going to equal x squared minus 3x minus 6. They want me to find G compose f of 5. All right, so notice this one's sort of in reverse order. They got the G of f of 5. So this one, if I was going to write it out into other symbols, would be G of f of 5. So for this one, we're going to find f of 5 first. So first, we find f of 5. Then, put that answer into the g of x. Okay, so the second function always gets evaluated first and put into the first one. Just like up here, we did a g first and put it into the f, okay? So that means we're going to start with f of 5. Well, f of 5 is going to equal this f function and put a 5 in for that x. So that'll be 3 times 5 plus 1. All right, order of operations, I multiply before I add. So 3 times 5 will give us a 15 plus 1, which equals 16. So since f of 5 was 16, we're now going to find g of that 16. So that 16 went right up into the g, okay? All right, here's my g equation. So that's going to give me 16 squared minus 3 times 16 minus 6. So these are mainly just a bunch of substitution type problems, okay? All right, so the first thing we got to figure out is 16 squared. And that is 256 minus 3 times 16 is 48. And then minus 6. All right, y'all, so now it's just time to subtract 256 minus 48 minus 6 gives us a total of 202. And that would be our final answer. All right, y'all, let me pull up my chat and see if y'all got any questions on these yet. All right, so no questions yet. All righty, y'all. So let's keep going then. All righty, let me see what we got here for the third one. So this will be the last of the ones where they gave me the numbers, and then they'll start just giving us variables, okay? So they do like three of each. All right, so this one, given f of x equals 3x plus 5, and g of x equals x cubed, they want us to find f compose g of a negative 5. So f compose g of negative 5 is the same thing as a f of g of negative 5. So on this one, we first will start with g of negative 5. Then put that answer into our f of x. All right, so let's start with our g of negative 5. That's going to equal negative 5 to the third power. All right, y'all, so what would that give you? Negative 5 to the third power. All right, so negative 5 times negative 5 times negative 5. Three negatives, we'll keep that negative. And then the 5 times 5 times 5 is 125. So negative 5 to the third power gives me a negative 125. So y'all, this negative 125 will now go into the f of x. So we're going to find f of a negative 125. Hey, y'all, so let's see what that gives me. That gives me 3 times negative 125 plus 5. All right, so multiply these first before we add. So 3 times negative 125 is a negative 375 plus my 5. And adding that negative 375 plus 5 gives me a negative 370. Final answer. All right, y'all. So for the other three, we're going to change the tune up, and they're not going to give me numbers for these. They're just going to give me the x variable here, okay? So since they're only giving me the x variable, I cannot simplify these to get a single answer like this because they're not giving me a number to put into it. So all we can do is simplify it, add like terms, and be done with them, okay? So for this one, they want me to find f of g of x. G compose f of x. So they want me to find both of these and the domain of each. So I'll find f of g of x first, g of f of x, then I'll tell it the domain of my f of g of x, and then the domain of my g of f of x, okay? All right, so let's start with f compose g of x. That is like f of g of x. Now, since I don't have a number for this one to do g of x with, what I'm going to do on this problem is I'm going to put the g of x function into the x's of f of x. Okay? Oh, y'all, I need my two functions, don't I? So let me write them down. f of x equals x plus 21. G of x equals x minus 21. All right, so there's my f and there's my g. So I'm finding f compose g of x first. So we said we're going to put the g of x function right here into the x of the f function. So basically we're finding f of x minus 21. Since g was x minus 21, that is now the variable we're putting in. So we take our x plus 21, in place of the x, we put x minus 21. So that'll give me x minus 21, and then I still have a plus 21. Okay, so it still looks like the f of x here, other than I put this whole thing in for that 1x. Now, the only thing I can do here is add like terms. But my like terms for the numbers are going to cancel. So all that's left on this one is an x. So that means f of g of x equaled x. All right, so now we're going to do g compose f of x. So that would be like g of f of x. Once again, they didn't give me a number. So what I'm going to do for this one, we're going to put the we're going to put the f of x function into the x's of g of x. Okay, so same thing, you're just putting the other function now. So if I'm going to put f of x into g, that means I'm finding g of whatever f of x is. And that's x plus 21. So we're finding g of x plus 21. So take this g function and put an x plus 21 in place of that x. So you're going to get x plus 21 minus 21. So now they're sort of giving us a mellow one to start out with, okay? All right, let's look here. Like terms cancel. So all that's left again is a x. Now, the reason we only got x's on these is because this function and that function, the only thing different was the plus and the minus on them. They had the same number and everything on these, okay? All right. So now it would ask for the domain of f of x. Um, so y'all let me find the domain. And this is the domain of f compose g of x. And they want these in interval notation, so we'll start at negative infinity, end at positive infinity, and kick out any numbers along the way if we got to. So y'all look at this. G of f of x was x plus 21 minus 21. So my question would be, if that's your function you're evaluating, are there any restrictions on this domain? Are there any numbers that we got to kick out of the domain? And there's only one thing I'm really looking for on this. Do we see any fractions? And y'all, I don't see any fractions that would make that undefined. So since there's no fractions here, this will work for negative infinity all the way to positive infinity. No restrictions on this problem. No matter what number you give me for x, I can add 21 and subtract 21 and be done. All right, so the domain of G compose f of x. Well, we was working that one right here. So G compose f of x give me x plus 21 minus 21. So once again, I do not see any fractions on that. So there's no way to get a zero in the denominator if you don't have a denominator, right? So that means there's no numbers I got to kick out of my domain. So this domain would be good for negative infinity to positive infinity. No restrictions. And you just got to remember the only thing we're looking at on these domains are do we got fractions in there that got a variable in the denominator. If not, I'm not kicking nothing out, okay? All right, so that's what happens when you got variables. Notice no numbers in the x's here, so I ended up with a variable on these answers, okay? Hey, y'all, let's try this next one then. All right, so for this one, f of x equals x plus 3. G of x equals 2x squared minus 5x minus 3. So we're going to do the same thing. We're going to find f compose g of x, g compose f of x, and the domain of each. Okay, so same problem. They're just turning it up a little bit on these expressions they're giving us. So y'all, let's start with f compose g of x. So once again, that is like f of g of x. So that means I'm going to be putting this whole g of x function into the f function. So I'm finding f of 2x squared minus 5x minus 3. Remember, when I put stuff into these parentheses with my f, this is telling us what we're putting in for our x's, okay? So here's the f. In place of that x, you're putting this 2x squared minus 5x minus 3. Now that's the x, and we still got a plus 3. All right, so all you can do, remember, is add like terms. You know, the only like terms I have are the numbers, negative 3 and 3, which cancel. So my final answer is 2x squared minus 5x. Cannot go any further on that. All right, y'all, well, I can tell us the G one's going to be the fun one. The G of f of x. So this one is like G of f of x, which means we're going to put this f of x function, this whole function will go into both of these x's on the G, okay? So we're going to be finding G of x plus 3. All right, so we got to be careful here because here's G. So I got 2 times x, which is x plus 3 squared minus 5 times x, which is x plus 3, and then minus our 3. A little more work on this one because of this x plus 3 squared here, okay? So let me do this one step at a time so y'all can follow me. So my first step, all I'm going to do is square the x plus 3. So I'm going to bring that 2 down. So let's do this on the side, x plus 3 squared. That is x plus 3 times x plus 3. Remember, anytime you got a binomial being squared, you got to write it twice and FOIL. So I get x times x is x squared. X times 3 is 3x. In the middle, 3 times x is 3x. And y'all finally, 3 times 3 is 9. Add the like terms and you get an x squared. 3 plus 3 is 6x plus 9. This now replaces that. So I got my x squared plus 6x plus 9. I'm just bringing everything else down now so y'all can see what I'm doing one by one. Next, I will multiply. I'm going to distribute a 2 here and a negative 5 here. And those are the only things I can multiply at the moment. So 2 times x squared is a 2x squared. 2 times 6x is 12x. 2 times 9 is 18. Negative 5 times x is a negative 5x. Negative 5 times 3 is negative 15. So remember, when you got a negative, you got to distribute that negative with that number, okay? And at the end, bring down that negative 3. All right, so all we can do is add like terms. So the 2x squared comes down. It's the only x squared term. All right, we got 12x's and negative 5x's. So 12 minus 5 will leave me 7x's. And y'all, let me see. I got my numbers, 18, negative 15, negative 3. So this makes negative 18 and 18. So that cancels. So the number cancels. So the final answer is the 2x squared plus 7x. So y'all just be careful of this kind of stuff because you got to foil when you get that, okay? All right, so let me do the domain of my f of g of x. And then we'll do the domain of our g of f of x. So I did my f of g of x up here. And here's the function we were evaluating when we put everything in. I do not see any fractions here. So since there are no fractions here, the domain is all real numbers, which will go from negative infinity to a positive infinity. And y'all, here was the g of f of x. Well, once again, no fractions are shown. So there's no way I can get anything to be undefined. So that domain will be negative infinity to a positive infinity. Okay, so I'm only looking for fractions. So y'all know the thing now, right? Since the first two problems with the domains didn't have any fractions, we know the last one is, right? So y'all, let's see what they did to us on this last one. So for this one, look here, f of x equals 3 over 1 minus 5x. So there's a fraction. And then g of x is going to equal 1 over x. So for the last one, they definitely gave me two fractions, okay? So we're still going to find f of g of x, g of f of x, and the domains of each. So I'm going to start with f compose my g of x. And y'all remember, that's like what? F of g of x. So we're going to put the g of x into the x of our f equation. So that means I'm finding f of 1 over x. Now, y'all, there's the x. So on top, I got a 3. Nothing happening to that. On bottom, I'm going to have 1 minus 5 times x, which is 1 over x. So I had to put this 1 over x into that 1x. Now, I'm going to lie. The trick on this one is to get this thing simplified, okay? So at the moment, the 3 on top. All I'm going to do on this step is multiply this 5 times the 1 over x. And if you want to, put you an imaginary 1 under the 5, because when we multiply numbers times fractions, we multiply straight across. So you're going to have your 1 minus 5 times 1 is 5 over 1 times x is x. So this is what we call a complex fraction, and we got to simplify this so that it either looks like a number or a regular fraction. Okay, we can't have a fraction inside of a fraction. So what you do, we're wanting to get rid of this fraction. So to get rid of this fraction, what I'm going to do is multiply all terms by x. Because I'm really wanting to get rid of this fraction. So I'm going to multiply the top and both of the parts on the bottom by x. So on top, I'll have 3 times x. On bottom, I'll have 1 times x minus my 5 over x times x. Remember, multiplying distributes over everything. And what we do to the bottom of a fraction, we got to do to the top, okay? So y'all, let's see what happens. 3 times x is 3x on the top. 1 times x is x on the bottom. But y'all, what happens here? My 5 over x multiplied by that x. Y'all, look here. Those x's cancel. All that's left is the 5. Now, this looks like a normal fraction. Cannot go any further. So that would be our answer. So look, when we do the domain, you got 2 places you got to worry about on this one. First off, right here, this x cannot equal 0. And then right here, this x cannot equal 5. So when we do the domain of this, we're going to kick out the 0 for that x and the 5 for that x, okay? All right, y'all. So here, first, we got to do g of f of x, which is like g of f of x. So I'm going to be finding g of whatever f of x is, and f of x was 3 over 1 minus 5x. So this will all go into that 1x on the bottom. So on top, I got a 1 divided by, and y'all, on the bottom, I got 3 over 1 minus 5x. So this is considered as one fraction on the bottom, and then you got your 1 on top. So to do this one, I'm going to multiply the top and bottom by the 1 minus 5x. You want to get rid of the denominator of the littler fraction by multiplying by what's in that denominator, okay? So that's going to give me 1 on top times 1 minus 5x. Because what I do to the bottom, I do to the top. And on bottom, I got my 3 over 1 minus 5x times 1 minus 5x. So y'all see what's happening, right? On top, you've got a 1 times 1 minus 5x. So the top will now be 1 minus 5x. But y'all look at the bottom. This 1 minus 5x canceled with this 1 minus 5x. So all that's left on the bottom now is a 3. This now looks like a fraction. So now that is our final answer. So the moral of the story, to get rid of the smaller fractions, we multiplied by the least common denominator, which was the denominator of the fraction. Okay? And you got to do it to all terms. Now here, this is one denominator. So I had to multiply it by the bottom and the top. Whatever you did to the bottom of these fractions, you have to do to the tops, okay? All right, y'all, so let's play with the domain of our f of g of x. Now, our domain will start at negative infinity, but we got to see what numbers we got to kick out. At this point right here, x cannot equal 0. Because if you put a 0 in, 5 divided by 0 is undefined. So we're kicking out a 0 for this one. And right here, the only number this cannot be is 5, because 5 minus 5 would make that 0. So I know x cannot equal 5 because of this one. So I got that from there and a 0 because of that. So you got to look at every step and see, are there places where you got these fractions, okay? All right, so let's see. 0 and 5, so 0 would come first. Union around 0 to 5, and then union around 5 all the way to positive infinity. Over here, we're going to do the domain of our G composed f of x. It'll start at negative infinity. All right, let's see. I'm worried about this place right here because I got a variable in my denominator. And y'all, as I look through, I'm not worried about this one because it's only got a number in the bottom. So the only place we're worried about is right here, the 1 minus 5x. That 1 minus 5x cannot equal 0. So what I would do is set 1 minus 5x equal to 0 and solve this for the x. And whatever number we get, we're going to kick out, okay? So let me start by subtracting 1. That gives me negative 5x equals negative 1. Divide both sides by negative 5. So that gives me an x. Negative 1 over negative 5 makes that a positive. And y'all, I can't do nothing with that, so it's going to be a 1/5. So that means for this one, x cannot equal 1/5 because of this place, okay? So that's the only number I don't have to keep in my domain. So my domain will go negative infinity to 1/5, union 1/5 to a positive infinity. So y'all, that, my bad, that was 9.1, composition of functions. Um, okay, let me think, Mackenzie. They would be really similar to mine, so they might would give y'all something like this. They might give y'all f of x equals 2 over 1 minus 3x, and then g of x is still going to be 1 over x. So the only thing they change on this problem are the 2 or the 3 on the top or bottom, okay? They don't change this one, and they don't change this one at all. Everybody will have a 1 of x on this one, okay? So y'all wanted another example of this one. So now listen here. We're still going to find f of g of x, g of f of x, and then the domains. So let me start with f composed g of x. That's going to be like f of g of x, okay? So we're taking our g of x and putting it into the f. So that means we're finding f of a 1 over x. So y'all, I got 2 on top over 1 minus 3 times 1 over x. Okay, so everybody will be substituting right here at this x. So y'all, nothing on top I can do at the moment. So that's a 2. I'm going to multiply 3 times 1 over x. So I'm doing this right here. So if you want to put a 1 under the 3, you can. Or just remember, single numbers can only multiply by the top of the fraction, okay? So bring this 1 down, minus 3 times 1 is 3 over 1 times x is x. If you don't want to put a 1 under here, just remember that this 3 only multiplies by the top. All right, so y'all remember at this point I said, well, I can't have this little fraction in this big fraction. So since the only part I'm worried about is that x in that denominator, I'm going to multiply the top and all the terms on the bottom by x. So that gave me a 2 times x on top over a 1 times x minus 3 over x times x. All right, so y'all see what's happening. 2 times x is 2x on the top. On the bottom, 1 times x is x minus, and y'all look here. Once again, my x's cancel, and I'm left with my 3. So, nothing else to do to that. It looks like a normal fraction now. So when we do the domain, we got this x here, remember? This one still cannot equal 0. So pretty much everybody will be excluding 0 on this problem for sure. And then right here, remember, a while ago, this was a 5, and I excluded 5. Well, now there's a 3 here being subtracted. So that means this x in the future cannot be a 3, because 3 minus 3 makes that 0. So my domain will kick out a 0 here and a 3 here. All right, y'all, g compose f of x is like g of f of x. So I'm finding g of f of x, which is 2 over 1 minus 3x. All right, so this is what I'm putting into that 1x. So I'm going to have a 1 over 2 over 1 minus 3x. So in a second, we'll probably set 1 minus 3x equal to 0 to see what this x cannot equal, because it's in the bottom of that fraction, okay? All right, so y'all technically on this one, let me write this problem down again. Since this fraction on bottom is the one I'm trying to get the denominator to be canceled, I'm going to multiply the top and bottom by 1 minus 3x. So on top, I'll have my 1 times 1 minus 3x. And then on bottom, multiply that one by 1 minus 3x. On top, multiply, you get 1 minus 3x. Because 1 times anything is the anything. Now remember on the bottom what happens, that 1 minus 3x canceled with that 1 minus 3x, leaving a 2. At that point, we have our fraction. All right, so nothing to worry about down here. So the only thing I'm really worried about was this denominator right here. So if you want to set 1 minus 3x equal to 0 and solve it, and I'm going to solve it the same way. That gives me negative 3 equals negative 1. Then divide both those by that negative 3. So that cancels. Negative divided by negative makes that a positive 1/3. So this number will be kicked out for this one. X cannot equal to 1/3. Over here, at this point, we said x could not equal 0. And then at this point, we said x could not equal 3. So first, the domain of f of g of x starts at negative infinity. We're kicking out two numbers, 0 and 3. So you hit 0 first, union around 0 to 3, union around 3 to positive infinity. Over here, the only number I had to kick out was the 1/3. So the domain of my g of f of x is going to be from negative infinity, kick out the 1/3, union around that 1/3, and then you're off towards positive infinity. So y'all, they're really similar. The only difference is I'm pretty sure between y'all and me is the 2 and the 3 might be different numbers on the first fraction. But y'all, this fraction will be the same. And then this one will be 1 minus whatever that number was, okay? Alrighty, y'all. So, we're really wanting y'all to realize that when we're looking at a domain, we're really only worried about fractions if they're there or not, okay? Alrighty, y'all. So my next section is 9.2, and this one deals with inverse functions. All right, so before we get into the functions, we're going to look at what an inverse is actually, okay? So, oops, let me do one thing first. So, to find the inverse of a relation, we simply switch the x and y values. So the first one, they're going to give me a set of ordered pairs. So to find the inverse of the ordered pairs, I'm going to switch the x and y values. Okay, so that's basically what we're going to do to these. And switching the x and y's is pretty much how I will find inverses even on the functions, okay? So for this first one, we're going to find the inverse of the relation. So the relation they're giving me, my first ordered pair is 3, 2. Then they're giving me 1, -1. Then they're giving me 8, -4. Then they're giving me 5, -5. There's the relation they're giving me. They want me to find the inverse. So here comes our answer. Now, MathLab automatically will give you the curvy brackets, but you got to put all the ordered pairs in parentheses with commas, okay? So it says here, switch the x and y values. So the 3 is x and the y is 2. If I switch them, I get a 2 comma 3. The next one, if I switch them, I get a -1, 1. The next one, I get a -4, 8. And y'all, finally, the last one, if I switch them, I get a -5, 5. That is now our inverse relation. All right, so watch this next one. Find an equation of the inverse relation. Same thing, they're just giving me a equation now instead of an actual set of ordered pairs. So this one, they got a x cubed y equals -5. So remember, to find the inverse of a relation, I switch the x and y. So y'all, I'm going to switch to x and y. I don't move the exponent, it stays there. All I'm going to do is switch the variables so that gives me a y cubed x equals -5. Okay, so not much on the first two problems. You're just switching. All right, so check this out. We're going to start talking about functions, okay? So for a function to have an inverse, it must be 1, 2, 1. So if you remember this, when we were looking at functions, every x could have one and only one y value. Okay? So what this means is one-on-one means every y value can have one and only one x value. Well, that makes sense if it's going to be the inverse of this. That means the y values can only have one x value. Okay? So it's almost opposite of a function, okay? Now, how can I tell if a graph is one-to-one? The way we tell if a graph is one-to-one is by, well, y'all check this out. If I was looking at a function to tell if it was function and the x's could only have one y value, I did a vertical line test. And remember, the graph couldn't intersect my vertical line more than one time. Well, if I'm looking at the y values only having one x value, these are going to be done by a horizontal line test. Okay? So the way we tell if a graph is one-to-one is by the horizontal line test. All right, y'all, and here's what the horizontal line test says. If it is possible for a horizontal line to intersect a graph more than once, so if you can intersect that graph more than once, the graph is not one-to-one. Okay? Just like the vertical line test for functions. If the vertical line got intersected more than once, it wasn't a function. Well, if the horizontal line intersects the graph more than once, it's not a function, okay? So what we want to look at is these three graphs here, and I'm going to make this just a little bigger and refocus. All right, so first question, y'all. This first graph coming up here, is this graph one-to-one, yes or no? And y'all, what you remember you doing? You're running horizontal lines across. So if you notice that only intersected once there, intersected once here. Anywhere I do my horizontal line, and remember, these asymptotes are getting closer, but they never get there, but they're never horizontal. So this one is definitely yes, because it passes the horizontal line test. What about this second one? Is this upside down parabola one-to-one? No, good job, y'all, because look here. If I run me a horizontal line, it's going to intersect on this side and this side. And it does that in a lot of places. It's intersecting it more than once. So good job. That makes that one a no. All right, y'all, you got one more down here. Is this third graph? 1 to 1. Look here, this one, it fails it up here, right, Mackenzie? It fails it right here. It fails it on the bottom. So these horizontal lines are getting hit twice everywhere. So this one would be a no, okay? All right, y'all, so that's what you're going to be looking at. So if you want to do one more, is this graph 1 to 1? So let's see. Looks like these horizontal lines are only intersecting at once, right? Once here. This is still going downhill, so it's only intersecting at once there. Um, Intersecting at once there. I mean, it ain't very steep, but y'all, these horizontal lines are only intersecting at once. So this one would be yes, 1 to 1. Okay, so that's what you're looking at. You're just looking at running that horizontal line across and seeing if it intersects it one or more times, okay? All right, y'all, so we're in here to deal with functions. So what we got to do is find an inverse for a function. Okay, so finding the inverse of a function. Okay, so the first thing, function must be 1 to 1. So you can look at a graph of it, graph that function real quick if you want to. And if it's 1 to 1, you can find that function, okay? All right, so these are the steps to actually finding the inverse of a function. The first thing we're going to do, we're going to replace f of x with a y. Because they're going to give you a f of x equals something. So since f of x and y are the same thing, basically, we're going to replace f of x with a y. Now I'm going to have y equals whatever. So remember, what's the main thing I got to do to find an inverse? What do y'all think is the main thing I'm going to have to do to find the inverse that goes along with what I was doing earlier? See what y'all think. Um, Mackenzie, you're sort of close. Um, Instead of flipping it, I would probably say switch the x and y. Um, but anyway, I can see how you could say flipping it on that, but you're switching that x and y variable, okay? Now what we do is we solve for y. We'll solve for y ever how you got to, okay? We're going to solve for the y. And then once we got the new y solved for, we're going to replace y with f negative 1 of x. F negative 1 of x, this right here, is what we call inverse function notation. So f of x would be my original function. F negative 1 of x will be my inverse function. And y'all, that's what I want to do to these, okay? So for the following functions, A, determine if 1 to 1. And then B, if 1 to 1, find the inverse. Now, I'll sort of show you how to check these. Um, but let me just tell you this. All of the problems from 7, 8, 9, 10, 11, and 12, those 6 problems, they're all going to be 1 to 1. But I'll show you why anyway, okay? So, y'all, the first one I'm going to do, f of x equals x minus 3. So that is my function. So if you want to see if it's 1 to 1, let's go to the calculator. And let's go to y equals, and let's graph x minus 3. All right, so I'm going to hit graph. Is that, and this is for y'all, is that function 1 to 1? And y'all, it looks, if you run horizontal lines all up and down this, they're never going to intersect it more than once. So good job, Mackenzie. This is definitely 1 to 1. So now that means we're going to find the inverse. So yes, 1 to 1. So find the inverse. First thing I did, I said, replace that f of x with a y. So replace f of x with a y. All right, so I switched my f and x um with a y. Now I got to switch to x and y variables. So this will be x equals y minus 3. So switch the x and y variables. Now you got to solve that for the y. Only one step to get this y by itself, and that's to move that negative 3 by adding 3 to both sides. So y'all, let's see what I get. Over here, I get an x plus 3. This side, the 3's cancel. All that's left is my y. All right, so I solved for the y. Now it says my last step, replace the y with f inverse of x notation. So f inverse of x, that's my y now, equals x plus 3. Now MATLAB will give you that, and you got to put in the actual function, okay? So check this out. If the original function was subtracting, the inverse is adding. They're really close on doing opposite operations every time, okay? So y'all, let me ask y'all, do y'all have a question on that? And we got plenty of these to do, okay? Well, we got 5 more, I guess. All righty, so let me bring that back up. All right, y'all, same thing. This time we're giving us f of x equals 6x minus 2. So let's go graph that and see if it's 1 to 1. So I'm going to go back to y equals. And this was 6x minus 2. And I'm just wanting to look at the graph. Well, y'all, once again, it's a straight line, and look at that. You can do horizontal lines all up and down that, but they will be 1 to 1, okay? So yes, it's 1-to-1. So we're going to find the inverse. We're going to replace the f of x with the y. Then we're going to switch the x and y. So switch them. That's going to give you x equals 6, y minus 2. All right, now we're going to solve for y. So y'all, the first thing I would do is add 2 to both sides, get that 6y by itself. So you're going to have an x plus 2 over here equal to your 6y on that side. These 2's are going to cancel on out of there. And then we want that to be a 1y, so we're going to divide both sides by 6. So there's nothing I can do to that, so that's going to stay x plus 2 over 6. But y'all here, 6 divided by 6 makes that a 1y. Can't go no further, so replace that with f inverse of x. And f inverse of x will equal x plus 2 divided by 6. So look once again. This was being subtracted. It's being added. This 6 was being multiplied. It's now being divided. Okay? So they actually have inverses of each other as you're going through these, okay? All right, y'all. So this next one is one of the trickier ones. They're giving me f of x equals 9 over x plus 6. All right, so let's see what that graph might look like. I'm going to go y equals, clear that. All right, I'm going to get fraction notation, alpha y equals enter. On top, I had, what, a 9? On bottom, x plus 6. All right, so let me look at that graph. So sort of like the stuff we graphed in 8.5 the other last week. But y'all, this is 1-to-1. It's just trying to get closer to the x-axis, but it never gets there. But it's never horizontal. It's always going down, down, and down. So this is definitely 1-to-1 again. So yes, 1-to-1. But y'all, like I said, they're all 1-to-1 on this section. I'm just wanting you to see the graphs, okay? All right, so it's 1-to-1. I'm going to replace the f of x with a y. So I'm going to get y equals 9 over x plus 6. Now, switch the x and y. So we're going to switch that x and y. So I'm going to get x equals 9 over y plus 6. All right, so you would treat the x like it had a 1 under it, technically. I'm wanting to solve for this y plus 6, so I got to get it on the top. So that means I'm going to multiply both sides by y plus 6. So on this side, I can't do nothing at the moment, so I'm going to keep it a y plus 6 times x. But y'all, this side, the y plus 6 is canceled. All that's left is a 9. Now, I'm not going to distribute that x because I'm solving for the y here. So to get this y plus 6 by itself, it's being multiplied by that x. I'm going to divide both sides by the x. So I'm going to have the y plus 6 times x divided by x equals 9 divided by x. Because this side, the x's cancel, and all that's left is the y plus 6. And this side will be the 9 over x. So y'all, let me show you what happened in the long run doing what we did. Up here I had the x on the left and the y plus 6. Basically, I'm just swapping them around. Because look here, the y plus 6 is now on the left side, and the x is now on the bottom on the right side. And that's a property when you multiply one fraction times another fraction, you can multiply or switch the top of one side with the bottom of the other side, and they're still equivalent, okay? So you can do that with fractions, but this is the process that would verify that you can do that, okay? All right, y'all, one more step to get to y by itself. Subtract 6 from both sides. That gives me my y. Those 6's cancel. These are not like terms, so I'm just going to keep that at 9 over x minus 6. All right, y'all, my last step was to replace the y with the f inverse of x notation, and that'll equal to 9 over x minus 6. So y'all, really with these, it's just trying to figure out the best way to actually get them solved, okay? All right, let's see what they gave me here. F of x equals x cubed minus 8. All right, so let's go graph that. So let's clear everything. So that was an x cubed, arrow right and come back down, minus 8. So let's look at that graph. And this one's going to be that little squiggly line. Now, it's not really flat here. It's just because you're seeing the tick marks. But this graph is going uphill left to right. So it's 1 to 1 again. So yes, 1 to 1. So I'm going to find the inverse. Replace f of x with a y. All right, y'all. So if y'all are with me now, let's see what's the next step. Okay, so let's switch them. So that gives me x equals y cubed minus 8. And y'all notice, I didn't switch the exponent. I left that exponent there. I'm just switching my variables. All right, y'all. So now let's solve this for that y. So to solve for y, I want to get this y cubed by itself. So we need to add 8 to both sides. So when you add 8, you get an x plus 8 over here equals my y cubed. Now, the way you undo exponents is like when we undid the x squareds, we use square roots. If you want to undo a y cubed, you do a cube root to both sides. So you're going to come in and cube root to x plus 8. That's going to equal a cube root of the y third. So radicals and exponents always undo each other. So y'all over here, I can't do nothing. Cube root x plus 8. But over here, the cube root of y cubed is a y. All right, then my last step, replace the y with the f inverse of x. And y'all, that's going to equal a cube root x plus 8. So remember, cube roots undo y cubes. Square roots undid x squareds and so on these, okay? All right, y'all, let's take a little break real quick. I didn't see it was already after 11. I'm going to pause this on a record. All right, y'all, so our next example, they're giving me f of x equals 5x squared plus 2. Now, y'all, this one has a comma, and then it says x has to be greater than or equal to 0. So let me show you what they mean by that. This is telling me they're not looking at no negative x values on this one, okay? They're only looking at the positive y values. So let's go look at the calculator and go to y equals and clear that. Now I'm going to show you what they mean when they say x is greater than or equal to 0. So first, let me just graph this. 5x squared plus 2. Now, if you graph it like this, it's not one-to-one because it's going to intersect it twice. So what they want you to do when they say x is greater than 0, they want you to go to the window and the smallest x value has to be a 0. They don't want you looking at negative x values. They're telling you that the x's have to be greater than or equal to 0. Now watch when you graph it. It only shows the right side of the graph. And if you're only looking at the right side of the graph, it's one-to-one. So they can make them one-to-one by limiting the domain values for the x's, okay? So that's what they mean when they put that x greater than equal to 1 on that one. All right, so let me go to zoom 6 and go back to normal. So yeah, that's what they mean on that. So it is one-to-one because they're restricting the domain. So yes, one-to-one. So anytime they sort of do this kind of stuff, that's what they're doing. All right, so it's one-to-one. We're going to replace f of x with a y. All right, switch to x and y. So I'm going to get x equals 5y squared plus 2. So now it's just a matter of solving for y. So subtract 2 first. You're going to get x minus 2 equals your 5y squared. So you can't take a square root until you get to y squared by itself. So divide both sides by 5. So nothing we can do over here. But y'all over here, the 5's cancel, and we're left with a y squared. And then remember, the way to get rid of the y squared to make it a y is to do a square root. So square root both sides. All right, so nothing we can do over here. So that's going to stay a square root of x minus 2 over 5. But y'all over here, the square root cancels the exponent, making that a y. And just like before, my last step is to use my f inverse of x notation for the y and put in my x minus 2 over 5. Okay, so now this one, they give you most of the answer. The only part that I had to put in for the answer, technically, was the top of that fraction. They had the square root and then a box here over a 5. So all I had to do for the answer was put in my x minus 2 and be done with it, okay? All right, y'all, one more of these and then we'll do support. So f of x equals a square root x plus 4. So if you were to graph that, let me clear everything. You would have a square root of x plus 4. All right, so when you graph it, it slowly goes uphill to the right, but it is 1 to 1. So good job. So yes, 1 to 1. So y'all, that means we're going to find our inverse. Replace the f of x with a y. Switch the x and y so that you get x equals a square root y plus 4. Now here's the biggest mistake I get on this one. People try to subtract 4 from this. You cannot subtract a number that's under a radical. Before I can move any of this, I got to get rid of that radical. And the way we undo radicals, well, over here, radicals undid exponents. So to undo radicals, we use exponents. So the way to get rid of this square root is to square both sides. So I'm going to square the x, and then I'm going to come in and square the right side. So you can't do nothing over here. That's going to be an x squared. But y'all, when you square a radical, this radical cancels with the exponent, leaving the y plus 4. Okay, so exponents undo radicals, radicals undo exponents. And y'all, the last step, subtract 4 on both sides. So I get a x squared minus 4 equals y. And now switch y with f inverse of x. And I get f inverse of x equals x squared minus 4. So these aren't bad once you get used to seeing what operations undo other operations, okay? All right, y'all, so that was 9-2. So now let me do the support. So 9-1 support had two problems. The first one, they're giving you k of x equals x plus 11. They want me to find k of 0, k of negative 9, k of negative 20, k of 20, and then k of d plus 3. So they gave me the function k of x, and they're just wanting me to find these 5 values. So this was getting you ready for the 9-1 when we did the g of x, put it all into the f and all that fun stuff, okay? So k of 0. Well, you're going to put a 0 in for the x, and you get 0 plus 11, which is 11. K of negative 9. You're going to put a negative 9 in for x plus 11. Negative 9 plus 11, positive 2. All right, next I had what? K of negative 20. Put a negative 20 in for x plus 11. Negative 20 plus 11 is negative 9. Then K of 20. Well, K of 20 equals 20 plus 11. And that's what? 31. And y'all finally, K of D plus 3. Put a D plus 3 in for the X plus 11. So y'all, that's for y'all. What would that final answer be? You got D plus 3 plus 11. All right, good job. Only got two like terms. So Mackenzie, good job. That's going to give me what, a D plus 3 and 11 equal 14. All right, y'all, for the second one in 9-1 support, they're giving me f of x equals 3x squared minus 4x. I'm going to find f of 0, f of a negative 1, and then f of a 2. So let me start with f of 0. I'm going to put 0 in for both x's. So I got 3 times 0 squared minus 4 times 0. Well, that's a big 0. That's a big 0. So I get 0 minus 0, which is a big 0. F of negative 1 will equal 3 times negative 1 squared minus 4 times negative 1. So the first thing you would do on this is negative 1 squared. So I'm going to bring down this 3. Negative 1 times negative 1 is a positive 1. And I'm just bringing the rest down because now I'm going to multiply this and this. So 3 times 1 is 3. Over here, negative 4 times negative 1 makes that a positive 4. And then 3 plus 4 is 7. So by hand, or like I said, you can punch this stuff right here into the calculator. All right, y'all, finally, f of 2. That's 3 times 2 squared minus 4 times 2. So I'm going to do the exponent again first. So I got my 3 times 2 squared would be 2 times 2, which is 4. And I'm bringing everything else down. Now I'll multiply these two and these two. 3 times 4 is 12. Negative 4 times 2 is a negative 8. And y'all, 12 minus 8 is positive 4. So that was the trick in 9-1, getting you used to plugging stuff in and evaluating, okay? And y'all, 9-2 had support. And in 9-2, the support is mainly refreshing you on solving equations. So it focuses a little bit, the first two doing what we call cross multiplying, and then the last 4 deal with radicals, okay? So let's do 9-2. So number 1, and these will all say solve. So solve this one. 6 over z plus 1 equals 5 over z minus 1. So when I got a fraction equal to a fraction, we got a little property. If a over b equals c over d, then a times d equals b times c. That means I can cross multiply and they're still equal. And that's how you're going to solve this. You're going to take this 6 and multiply by the z minus 1. So on one side, you got 6 times z minus 1. That's going to equal to z plus 1 times that 5. So that'll be like 5 times z plus 1. This is where you do cross multiplying. Okay? Now, I write it like this so that you realize the 6 multiplies by the z. The 6 also has to multiply by the negative 1. So you're going to get a 6z minus 6. And over here, the same thing. The 5 multiplies by the z, gives me a 5z. And then that 5 has to multiply by that 1, giving me a 5. All right, now to solve for z, I'm going to move my z's to the left side. So I'm going to subtract 5z from both sides. That there will give me a z minus 6 equals, well, those cancel, so all that's left is the 5. And y'all finally move the 6 over by adding 6. And I get z equals 5 and 6 is 11. All right, number 2 is cross multiplying. They had a z plus 2 over z equals 6 over 5. So same thing, that z plus 2 multiplies by the 5. So that'll be 5 times z plus 2. That's going to equal this z times that 6. So 6 times my z. All right, y'all. So over here, 5 times z is 5z. 5 times 2 is 10, equal to my 6z. Now, I'm going to tell you the trick on this one. Since there's only z's on this side and there's no numbers, this side has z's and numbers, I would move the z's to this side, and that'll leave that number there and the z's over here. So that's the easiest way to solve this, because if you subtract z, then you got to move the 10, then you got to take care of the negative. So a lot more work. So this one, the easiest step is to subtract 5z from both sides, so that cancels and you're left with your 10. And look at this. 6 minus 5 is 1z. So z equals 11 for 1. Z equals 10 for number 2. So y'all, those, like I said, deal with cross multiplying. The rest of these deal with square roots and cube roots. So we're going to solve this one. 4x minus 13 equals 1. All right, so remember, I can't add 13 or nothing yet because it's under that square root. So I got to get rid of the square root first by squaring both sides. All right, look what happens. The exponent cancels the square root, leaving you a 4x minus 13. Over here, 1 squared is 1 times 1, which is 1. So now it just becomes a matter of solving for the x. So since I only got the x's on this side, I'm going to move all the numbers over here. So add 13. I get 4x equals 14. Divide both sides by 4. So that cancels. I get my x. All right, 14 over 4. You can't divide it, but this will reduce. And it'll reduce because both of these divide by a 2. So 14 divided by 2 on top gives me a 7. 4 divided by 2 gives me a 2. So the final answer was 7/2. All right, y'all, watch the difference on this one. Square root of 5x plus a 4 equals 17. This 4 is not under the radical. So my first move would be to subtract 4 from both sides. You want these radicals by themselves before you do those square roots and square them, okay? So this gives me a square root of 5x. Those cancel. 17 minus 4 is 13. All right, so I'm trying to get rid of this radical now. So I got to square both sides. All right, so the radical cancels the exponent, leaving the 5x. 13 times 13 is 169. All right, y'all, my last step. Divide both sides by 5. So that gives me a 1x. And y'all, I can't do nothing to that, so I'm going to keep that at 169 over 5. Final answer. Okay, so it's just a matter. If the numbers are not under the radicals, you can move them. If they are under the radicals, you got to do the square first, okay? Oh, y'all, there's just two more of these. Let's see. This one has cube root of x equals -1. So this cube root of x is all by itself. So to get rid of that cube root, we're going to raise each side to the third power. And that's going to equal -1 to the third power. So y'all, this side, they cancel, right? The cube root cancels with the exponent, leaving my x. -1 times -1 times -1 is a -1. Now watch this one. Cube root x plus 1 equals 2. So look, that one's under the cube root, so I can't move it because it's under the radical. So my first move is to get rid of the radical, just like I did here. So I'm going to cube both sides. You raise it to the exponent that matches that number in the radical, okay? So we're going to cube both sides. All right, so that radical cancels that exponent, giving me an x plus 1. 2 times 2 times 2 is 8. And y'all, my last step, subtract 1 from both sides. And then 8 minus 1 is 7. So if you put a 7 in here, 7 plus 1 is 8. Cube root of 8 is 2. So, y'all, 9-2 support was just getting you used to cross multiplying and solving some of them radicals, okay? Um, and that's what helped you in 9.2 when I was solving equations. Remember, some of them had radicals and all that fun stuff. So that was the main thing for that section. All righty, y'all have any questions for today? All right, so let me stop my recording.